Hello friends, welcome to today's session. So today I'm recording this session without my video because my camera is showing some problem. So let's go directly into the discussion. Today we will be discussing a nomenclature which is not very popular but very important in many regards, is the A nomenclature, and commonly sometimes it is also said as to be replacement nomenclature. So what exactly it is? Actually, there are some function group just which are always non-terminal. The function group which are non-terminal, just like ether or a thioether or any secondary or tertiary amine, something like this. These are non-terminal function group, and very rarely in organic chemistry we do also see somewhere silicon in the organometallic compound. This is non-terminal, or selenium. At times you would see these. So majorly the when we talk about replacement nomenclature, is a nomenclature when somehow because of some reason we are not able to write their conventional names. So whatever the conventional names of these heteroatoms are there in their nomenclature, if you are not able to use that, then we generally adopt this nomenclature which we call it as a nomenclature or replacement nomenclature. Let me explain what do I mean by it. Say for example, this particular thing which we have wrote here is a ether, and if I just would pick the longest carbon chain is of 2 carbon and there is no double or triple bond, so it is ethane. And now coming on to the functional group part, here you would see there is 1 carbon only, and this is called as methoxy. So I would simply write 1 meth and along with this oxy. So I used the color combination so that you could understand everything categorically. So this is methoxy, this is oxy, meth, oxy, eth is the longest chain, and this is. Now the point here is the conventional naming of any ether in the IUPAC, we simply say it as alkoxy. Ethers are the class of compound in which 2 times alk is coming. Alkoxy alkane. You are able to see there are 2 times the alk part is coming, and this 2 alk parts are disjoined through the oxygen. In between the 2 alk part there is oxygen here, just like in the next case also. If you could see, this is the longest carbon chain, 1 2 3 4, and this means it is butane. Butane is the longest carbon chain. On to the second position, what you are able to see here is this is 2 carbon, so it is 2 ethoxy. So I think I made my point clear. It is a conventional naming. This is the conventional naming which we generally knew about it. Now the coming on to the let's say I have this compound with me. In this, if you could see, still I could write its conventional naming, because the longest carbon chain here I could see is 1 2 3. Some other fellow can use it like this also, 1 2 3. Now you know for sure that there is a rule in the conventional naming that if 2 subsequents of same seniority are at identical positions from the 2 ends of the carbon chain, then preference is given in the alphabetic order. Now here I have 2 ways of selecting the chain. One way is this, the one which I marked it with green, and another way is this. So which way I should go? Because if I could see on this side, I could see this is methoxy, because there is carbon here, although they would not show it, so we have to consider this as methoxy. And here you are able to see ethoxy. There are 2 carbon atoms. So both of these are having same preference order because both of these are ether. When 2 functional groups of same seniority are at identical positions from the 2 ends of the carbon chain, the numbering would go in a alphabetic order. So if numbering has to go in the alphabetic order, so I should omit this green marking, because ethoxy would come first in the alphabet. So it is 1 2 3. 3 means prop, so I should write its name prop, and this prop did not have any double or triple bond, so it is propane. So what name should I say here? 1 ethoxy, 3 methoxy, 3 methoxy propane. So this is a conventional name which we have just wrote it. Now if the situation got we got a situation like this one, the one which I have wrote here. So here what should I say? So if I would mark it like this, 1 2 3 4, or what should I speak? If I would say this is ethoxy for sure, and this is methoxy for sure, What about the, what would be said about the center one? So this is, what should I say about it? Is it ethoxy? And then what way I should write its name? So it is confusing. So here comes the replacement nomenclature, where you are not able to address the name of an organic compound with a conventional ruling. Then we are going to adopt replacement nomenclature. Now, how is it to be used? Now there are two ways to number it. One is 1, 2, 3, 4, 5, 6, 7, 8. So I selected the longest carbon chain in this way, where oxygens are counted as carbon. I numbered it as 2, 4, 6. Other way around is, if I would go this way, 1, 2, 3, 4, 5, 6, 7, 8. So first is which way I should go. Obviously the one which we have written with the pink one is the correct one, because in that case second position is on the second position is for the oxygen. Here you are getting third position. If I mark it with green one, so I am able to see it, the first function group is at the third position. So as per our lowest set of locants rule, you have to select that chain which would get the position of function group a least number while going from any direction. So that means pink one is the correct one. So now in the pink one, if you would just see once again that there is no double or triple bond, so I just would write it as oct, because there is 8 atoms I have selected and there is no double or triple bond, so it is octane. But actually it is not octane, because the second, fourth and sixth position did not have carbon in it. So here what I am going to use a prefix, we will say it as trioxa. So this is the replacement nomenclature. So I used a term trioxa. So this you always have to remember. So make it a point, they can ask you a question in a reverse way also. They will give you a question like 2,4,6 trioxa octane. They simply would ask you how many keto groups in it or how many oxo groups in it. So make it a point, oxo is a prefix. Oxo is a prefix for ketone part. Make it a point. This is a, when you use a term oxo, oxo pertains to a prefix which we used for ketone. Here it is written as 2,4,6 trioxa octane. Oxa means it is ether, but we are not able to use this ether as alkoxy. So that is why in an open chain, if more than 2 times O alkoxy group come into the picture, then we will be using this replacement nomenclature as oxa. Another question they can ask you is like this also. They will say the IUPAC name of some compound is 2,4,6 trioxa octane. How many oxo groups in it? So oxo groups are 0 in it. So there is no keto group. Or second question they can ask you is 2,4,6 trioxa octane has how many carbon atoms? How many carbon atoms? Those who are not aware of this nomenclature, they will say 8 carbon atom. But no, it is having 5 carbon atoms. So this also is very important. Let me take one more example here also. So here if you would go from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I would go from this 1, 2, 3, 4, 5, 6, 7, 8, 9. So the conventional lowest set of locants rule would be applicable here, because it is in the second position here. And if you would see, this is on the second position, and here also it is on the second position. So we have to go for the next one. So here if you could see, the ether part is on the fourth position. Here it is on the sixth position. So obviously I will go for the blue marker or blue written numerals I would go for. So what is the name? It is nonane, non and ane. There is no double and triple bond, but this nonane did not have all the 9 carbon atoms. In fact, on to the second, fourth and eighth position you have trioxa. So I made my point clear. Again, that oxa nomenclature would be used for ether when you are not able to use its conventional name as alkoxy. And in the cyclic form also you can use it. Just like here in this case, 1, 2, 3, 4, 5, 6. If I would write 6, it is cyclohex. And there is no double triple bond, so it is cyclohexane. But 1 and 4 position has dioxa. This is the way it is to be written. We may take one more example. If in case you have this sort of a nomenclature, this type of a compound, say for example, this is a Spyro compound, let's say, if you have this compound. So for this you refer to the Spyro nomenclature, but I directly would use here, this is bridgehead, and next the numbering would start from the bridgehead next to the carbon next to the bridgehead in the smaller ring. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what shall be the name? Spyro. First we write the Spyro word, then simple square brackets. It is to be written in the ascending order. Numbering is to be number of carbon atoms is to be checked in the ascending order. It is 3 on this side, 1, 2, 3, 4, 5. So 3 and 5, 8, and 1 is 9. Bridgehead atom is 9. So it is nonane. But again, it is not nonane. Fifth position is carrying. We will be saying 5-oxa. So I think I made my point clear. So you can see into the bicyclo and Spyro compounds using replacement nomenclature in the separate video already in the playlist. Similarly, if instead of ether you have a thioether, sulfur stands for thioether. Thioether. This is a thioether. It can be used as a non-terminal function group. So here also 1, 2, 3, 4, same viewpoint we can take it. There are 8. So 8 means oct, and all are single bonds, octane. So what prefix we will use for this? 2, 4, and 7 is having trithia. Here it is very important to remember, it would be said as trithia. So thia is a replacement nomenclature which we use for sulfur. This is the point which is to be kept in mind. Similarly, for another one is the nitrogen, especially the secondary nitrogen or the tertiary nitrogen, where you cannot use the conventional name. Here what shall I write here is just like 1, 2, 3, 4, 5, 6, 7. So 7 means hept, and all are single bonds, so we will be saying heptane. Now what I am able to see, first, 4th, and 6th can be said as to have triaza. This is very, very important. Triaza. Make it a point. Let me take one more example here. Just like if you have this compound with you, something like this. Okay. So what shall I be using? What name I should give it to this? 1, 2, 3, 4, 5, 6, 7, 8. So 8 means oct, ane. And now what you are able to see is 2, 4, and 6 is having triaza. This is very, very important. At times they can ask you, they will give you this name. They will say the IUPAC name of this compound is something. IUPAC name of some compound is 2,4,6 triaza octane. So they can ask you how many azo groups are there. Azo groups are there in above compound, in above name or above compound, for which the nomenclature is this. So make it a point, azos pertains to this functional group. So we will be saying it would have 0 azo group. There is no azo group. Just like the example I have taken for oxa may get confused with oxo. Oxo is a prefix of a ketone. Similarly, azo is a prefix for this function group, where just like we used to say, if I will place 2 phenyl groups, is this is azobenzene. This we commonly say it like this. And similarly, this aza can also be used in the cyclic form also, just like 1, 2, 3, 4, 5, 6. So this means it is cyclohex. All are single bonds, so cyclohexane. In the cyclohexane, we are able to see 1 and 4 is having diaza. So this aza, you have to keep it in mind. So I think I made my point clear. So these are some of the names which you always have to remember. Similarly, if you have, which is very rarely we would see, silicon or selenium, or as a matter of fact phosphorus, at times we can see in the some of the typical organometallic compounds, or something in terms of tin or lead or aluminium. These are the some of the elements which can also be getting attached with what you call it as organic moiety. Then these can also be said as, this is called as Sela, this is called as Selena, this is called as Phospha, and this is obviously would be called as Almina, and this is called as Zinca. But this is very rarely, we would not be seeing much about it. So basically, from the IIT point of view, or from the NEET examination point of view, or from the +2 level, because replacement nomenclature in itself is a quite a detailed one. If you would go into the rulings of a nomenclature, it is quite a detailed one, which would be used many times in many topics in a heterocyclic organic compounds which are having a medicinal properties as well. So I hope the things are clear. So let me sum up. This is the which we shall be using oxa. Then this is called as not sulfa here, it is thia. And here you have, if you have NH type of a, and this is called as aza. These are the principal one which you always have to remember. Thanks a lot. Have a nice day. Hope you enjoyed today's session, and hope to see you in some other nomenclature video very soon. Bye bye. Take care.